Welcome to CH225 course on Statistical Data Analysis for Chemists. I am your instructor, Anil Kumar. These are my contact details. This is video 27 in this series. In this video, we will learn the applications of Z and sampling distribution in real-world problems. Before we start, let us quickly review the important aspects which we will use in this video. We learned, in the last video, how to predict population mean using a single sample from a population whose standard deviation was known. This was the expression we used. Here mu refers to population mean, x bar refers to sample mean. Z is the standard normal variable, and alpha is the percentage significance level. And sigma by square root of sample size is the error in prediction. We also learned how to predict probability for any random continuous variable if the distribution is normal, using this expression coupled with Z table. We also learned about the application of continuity correction to predict probabilities for discrete variables. It is important to remind you all about the generalized version for the prediction of population mean. It is, the population parameter is equal to its estimator, plus minus, the confidence interval, multiplied by error in estimation. At this stage, it will be appropriate if we learn the generalized expression for converting a normal random variable to its Z variable, as shown here. Remember, mu is the expected value of random variable x here. And sigma is its standard deviation. Therefore, the whole expression for Z can be rewritten as the random variable minus its expected value and divided by its standard deviation. Now, in case of sampling distribution of mean, the random variable was sample mean, represented as x bar. Its expected value was mu. Its standard deviation was sigma by square root of sample size. Therefore, the standard normal expression for sampling distribution of mean will be as shown here. We will be using these expressions for solving the real-world problems discussed in subsequent video. Before we proceed to solve the questions, it is important to learn the process to be followed for this. The very first step in problem solving is to read each question multiple times to understand what is given and what needs to be calculated. Next step is to understand the approach which you will be following to arrive at the final answer. Now, carefully execute the steps to get the right answer. Next is to do the revision to make sure your approach and answer are correct. Here is the first question. Please pause the video here and try to solve this using the process explained just now. Once you complete the solution, play the video to confirm the solution. Here is how one should proceed to solve this questions. It is an example of a binomial distribution. Let x be the random variable which favor the candidate. Therefore, we have binomial with n equals to 200 and probability of success, p, as 0.46. We need to find out the probability of x equal or greater than 100. We will use continuity correction, as x is a discrete variable. Therefore, the desired probability will be x greater than 99.5. Therefore, we need to first calculate the corresponding Z value. we need expected value and standard deviation of the distribution to calculate z. For binomial distribution, expected value is n times p. The standard deviation is the square root of n times p times 1 minus p. Therefore, z comes out to be 1.0641. This mean, the probability of x, greater than 99.5, is same as probability of z greater than 1.0641. This value comes out to be 14.4% by using z-table. Therefore, the probability that at least 100 favor this candidate is 14.4%. Here is the next question. Please pause the video here and try to solve this. Once you complete the solution, play the video to confirm the solution. Here is how one should proceed to solve this question. In this case, it is given that 12% of the students get an A grade. Therefore, 88% of the students get lower than A grade. Therefore, we need a z-value, where probability of z less than this value has an area of 88% below it. Using z-table, we found that a z-value of 1.18 has area of 88% below it. Therefore, z is 1.18 for the cutoff for a grade. Let us assume that the marks for cutoff for A are x. Now the corresponding z-value for this x is 1.18. The expected value for x is the average score, and that is 74. The standard deviation for the distribution of marks is 7. Therefore, we can calculate x, as we know its expected value, standard deviation, and z-value. X comes out to be 82.26. Therefore, the lowest for A grade is 83, and highest for B grade is 82. Here is the next question. Please pause the video here, and try to solve this. Once you complete the solution, play the video to confirm the solution. Here is how one should proceed to solve this question. In this case, sample size, sample mean, and population standard deviation are given. We need to find out the range for the prediction of population mean for different confidence interval. Therefore, we will need to use the following formula. Now for 95% confidence interval, we need to leave 2.5% area on either side. Therefore, the corresponding z0.025 comes out to be 1.96. Now, we have all the information required to calculate the population mean range for 95% confidence interval. The calculated range comes out to be from 2.5 to 2.7. In the similar fashion, we can calculate the range for 99% confidence interval. The calculated range for 99% confidence interval comes out to be from 2.47 to 2.73. As expected, the range is higher for higher confidence interval.